Welcome to all of you. My name is Saorabh Mandal, Assistant Professor of AEI Department, Haldia Institute of Technology. Today I am going to discuss a circuit theory topic, which is Introduction to Network Graph Theory. Before going to the details, first we have to know what is graph theory. Graph theory is nothing but the discussion of a particular circuit and the circuit's elements and the details analysis in terms of graphical representation. So to know better about graph theory, we have to know some terminology. So these are the graph, node, branch, etc. What is graph? It is the geometrical interconnections of the elements of a network. What does it mean? Geometrical interconnections. That means basically inside that particular graph, branch and node is present, and the geometrical interconnections of that branches and nodes are nothing but that graph of that particular graph theory. It consists of a set of nodes connected by branch. So many nodes which is connected by branch are present inside the graph in graph theory. Node. A node is a common point of two or more branches. So when two or more branches are connected, then that connected position or connected point are nothing but called node. That means node is the common point of two or more than two number of branches. Branch. A branch is a line segment that connects two nodes. So whenever two node is connected, that line segment is nothing but called branches. And graph is nothing but the connection of that node and branches which is coming from a particular circuit. Any electric circuit or network can be converted into its equivalent graph by replacing the passive elements and voltage sources with short circuits and the current sources with open circuits. So whenever we have to convert a circuit into a graph, then what we have to do? We have to convert all the passive elements and voltage source by short circuited and all the current sources by open circuited. That means if any current source is present in that particular circuit, then we have to open that particular portions, and if any passive elements, that means say capacitor, resistor, such type of passive elements are present, that will be short circuited. If any voltage source are present also, that will be short circuited, and by doing this short circuit and open circuit, ultimately we can convert a circuit into a graph. This is one example, and in this example we can see what a particular circuit, and in that circuit what we are observing? We are observing total 4 nodes. Node 1, node 2, node 3 and node 4. So in that particular 4 node and other, in between this node the branches are connected. That means in between 1 and 4 one voltage source is connected, in between 1 and 2 one 5 ohm resistor is connected, in between 2 and 3 one 10 ohm resistor is connected, in between 2 and 4 one 10 ohm resistor is present, in between 1 and 3 one 30 ohm resistor is present, and in between that 3 and that particular 4, because this point and this point are short circuited, so in between 3 and 4 one 4 ampere current source is also present. So whenever we are converting this particular circuit into a graph, then what we will do? We will short circuit that 5 ohm resistor, 10 ohm resistor, 30 ohm resistor as well as 20 volt, and we will open circuited that 4 ampere current. And by doing this short circuit and open circuit, we can convert the graph. So this is the converted graph from the above circuit. Now here that node 1, node 2, node 3 and node 4, all 4 nodes are present, and in between that node the branches are present, which is denoted by A, B, C, D, E, F. So if we are observing the circuit again, we can see that one node 4. So node 4 is common for that case of the negative of the battery. The one part, that means one leg of the 10 ohm resistor, one leg of the 20 ohm resistor and the negative part of that particular 4 ampere current source. So from that particular portions, what we are observing, that means this is the common portions. So though it is the common portion and point 4, that means node 4 is the common portions. So whenever we will convert it, that particular graph, then all the D, E, F all will connected to node 4 in this way, and we can get a graph from that above circuit. Now in that particular graph, how many nodes are there? Node 1, node 2, node 3 and node 4. And how many branches are there? Node branch A, branch B, branch C, branch D, branch E, branch F. That means total 4 nodes and 1, 2, 3, 4, 5, 6 branches. So what we can get the conclusion from that conversions? We can conclude that the number of nodes present in a graph will be equal to the number of principal nodes present in the electric circuit. That means how many numbers of nodes are present inside the original circuit. After converting the graph, the number of nodes will become same. So number of nodes will be equal. The number of branches present in a graph will be less than or equal to number of branches present in an electric circuit. Now for that case of branches, the number of branches of inside the graph will be either equal or less than with respect to the number of branches present in an original circuit. Why? Because if any current source is there in original circuit, that will be open circuited. That means that branch will not be present. And though that branch will not be present, so the number of branches for that case of graph will be either equal or less than with respect to number of branches present in an original circuit. So number of nodes will be equal, but the number of branches either will be equal or will be less than with respect to original circuit. These are the various types of graphs. The first one is connected graph, the second one is unconnected graph, the third one is directed graph, and the fourth one is undirected graph. So one by one we'll see what is connected graph, what is unconnected graph, what is directed graph, and what is undirected graph. This is connected and unconnected graph definition. What is connected graph? If there exists at least one branch between any two nodes of a graph, then it is called as a connected graph. What does it mean? Means what graph we can convert from the circuit inside that graph if any branch is present in between any two nodes. That means if no nodes will become isolated, all the nodes are connected with branch, then it is called connected graph. That means no nodes will be isolated inside the connected graph. All nodes will be connected to any branches. So for that particular case, what above graph we have seen, the graph is nothing but a connected graph, because here no nodes are isolated, the branch is present in between two nodes. But for that case of unconnected graph, it is just the opposite. That means if no branches is present in between two nodes, any in between two nodes, then that graph will called the unconnected graph. See, here we can see node 1 and node 2. In between node 1 and node 2, no branches is present. That means node 1 is totally isolated. It is not connected with any branch. That's why this graph is nothing but called unconnected graph. So if any node is remain isolated inside a graph, then that graph is called unconnected graph. And if all the nodes are connected with a branch in a graph, then that graph is called connected graph. Now directed and undirected graph. What is directed graph? If all the branches of a graph are represented with arrows, then that graph is called as a directed graph. That means if all the branches are indicated the current flow directions by arrow, then that graph is nothing but called directed graph. Here we can see in this particular graph all the branches are indicated the current flow with the help of the arrow sign. In that particular A branches, the arrow sign is from 3 to 1, node 3 to node 1. The current direction is node 3 to node 1. For that case of branch B, it is node 1 to node 2, the current direction. That means for every branches, the current direction is there. So for that particular case, it is called the directed graph because it will mention the direction of the current flow. But for that case of undirected graph, no such type of current flow direction is mentioned to any branches. So if no current flow direction is indicated by arrow to any branches inside a graph, then that particular graph is called undirected graph. That means it is not indicated the direction of current flow. Here we can see no arrow signs are there which will indicate the current flow. So this graph is nothing but called undirected graph. So directed graph indicates the current flow direction, undirected graph does not indicate the current flow direction. Now subgraph and its types. So what is subgraph? Subgraph is nothing but a part of a graph. So whenever we are considering a part of a graph, then it is called subgraph. Now how many types of subgraphs are basically there? Basically two types of subgraphs are there. One type is known as tree and another type is known as co-tree. So tree and co-tree both are nothing but subgraph, and subgraph is nothing but the part of a graph. Now what is tree? Tree is a connected subgraph of a given graph which contains all the nodes of a graph, but there should not be any loop in that subgraph. What does it mean? It means that that tree is nothing but a subgraph, that means part of a graph which contains all the nodes of a graph. Inside a graph, how many numbers of nodes are present? In that particular tree subgraph, same number of nodes will be there, but there will not be any closed loop inside this. So that graph is totally open, no such type of closed loop is present there. If we can design such type of subgraph, then it is called tree. So tree does not contain any loop, but definitely will contain the same number of nodes with respect to the original graph. So this example is indicating the tree. Here we can see the node 1, node 2, node 3, node 4. That means all the 4 nodes are there like the original graph. But in this particular subgraph, no closed loop is present. So it is a tree. Mandatorily only this one will be tree, it is not like this. So this is also the tree. This is 1, this is 2, this is 3, this is 4. This is also a subgraph and this is also known as tree. Here also you can see node 1, node 2, node 3, node 4. All 4 nodes are present but no closed loop is present. So this is also called a tree. Now from the above tree, what we can conclude? We can conclude that the number of branches that are present in a tree should be equal to n minus 1, where n is the number of node. What does it means? In a tree, the number of nodes will be equal with respect to original graph, but the number of branches will be n minus 1. That means the number of branches will be 1 less with respect to number of nodes. So if number of nodes is n, so the number of branches will be n minus 1. So if number of nodes is 4, so number of branches will be 4 minus 1, 3. Here number of nodes 1, 2, 3, 4. But number of branches 1, 2, 3. So 4 minus 1, that is 3. And one more very important thing, the branches of a tree is known as twigs. So the name of the branches of a subgraph tree is called twigs. This is core tree. What is core tree? Core tree is a subgraph which is formed with the branches that are removed while forming a tree. What does it mean? That means tree and core tree both are the subgraph of a graph. Now, during the time of designing tree, what branches we are considering? During the time of designing core tree, another branches we will consider. That means which branches were left during the time of designing tree, that branches we will consider, and by considering that branches, what subgraph we can design? That subgraph is nothing but called the core tree. That's why it is indicated core tree is a subgraph which is formed with the branches that are removed while forming a tree. So when forming a tree, what branches are removed, that branches we will consider, and by considering that branches we will design a core tree. So in that previous slide, what we can see here, which one we are consider, we will remove? We will remove the branches in between node 1, node 2, in between node 2, node 3, and in between node 1 and node 3. So that 3 branches we are removing here to design a tree. So whenever we will design core tree, we will consider the branch which is in between node 1 and node 2, node 2 and node 3, and node 1 and node 3. So by considering that 3 branches in between node 1 and node 2, node 2 and node 3, and node 1 and node 3, we can design core tree. And one important thing is that the branches of core tree are basically indicated by dotted. So these dotted lines are nothing but indicated the branches of core tree, and this graph is basically called the subgraph, is known as core tree. And the name of the branches present inside the core tree is called links or chords. So its branches are called as links or chord. In general, the links are represented with dotted lines. So the branches of core tree are represented by dotted lines, and the name of the branches of core tree is known as links or chords. Now, how many number of branches will be present for that case of core tree? There also a formula, and that formula equals to L equals to B minus N minus 1. So the number of branches that are present in a core tree will be equal to the difference between the number of branches of a given graph and the number of twigs. Mathematically, it is written as L equals to B minus N minus 1. What is N? N is nothing but the number of nodes of original graph. What is B? B is the number of branches of original graph, and L is nothing but the number of links. That means number of branches of core tree. So L equals to B minus N minus 1. So what is the node number of original graph? 4. So N equals to 4. That means N minus 1, that is 3. And for that case of B, it will be 6. the value of B is 6 for that case of original graph. So 6 minus 3, that will be 3. That means L equals to B minus N plus 1. So B equals to 6, N equals to 4. So 6 minus 4, that is 2 plus 1. That means 3. So the number of links present in core tree for this type of graph is 3, which is this. So here total 3 links or chords are present, which is in between node 1, node 2, in between node 2, node 3, and in between node 1 and node 3. So the formulation is L equals to B minus N plus 1, where L equals to number of links, B equals to number of branches present in a given graph, N is the number of nodes present in a given graph. And one more thing, which is if we can combine tree and core tree, then we can get the original graph. Why? Because I already told that which branches were removed during the time of designing tree, that branches are considered to design core tree. So if we can combine tree and core tree, that means all the branches will be there and all the nodes also will be there, so we can get the original graph. I can elaborate further in next session the various matrices present in graph theory, by which we can analyze all the elements inside the particular circuit more clearly, and I think we can little bit understand the idea of circuit graph theory. Thank you everyone.